Hello, everybody. We're just letting everybody join right now, and my name is Ken Logadick. We're going to let everybody join right now onto the session. We're just set for a virtual open house for civil engineering today. We'll let everybody join for about 1 more minute, and then we'll start it up. So please join. Make sure your audio works, and make sure you can hear me. I know I'm a loud person. I've been told that a few times, so hopefully you can hear me. And then we'll get cruising here. Put anything you need in the chat box. Any questions you have, we'll try to monitor it as we go along. And we have about a 30-minute session planned today, and it's going to be action-packed, I hope.
Do you see my chat box comments coming up?
Perfect. Okay, everybody, welcome to the Civil Engineering Technology Battle Royale. Chris and I are going to battle it out for spaghetti towers to have some fun here. But just to introduce before that, just welcome to the our open house, virtual open house, sorry, for Okanagan College. Usually we have a career fair, but today it's a virtual open house. So we're going to do a bit of different stuff here with it, the virtual open house, because of course with COVID, as you can see, even Chris and I we actually have this COVID protection between us. I don't really want to be close to them, so I'm good. So we are COVID protected here, and we're going to talk about that throughout our labs today, throughout our program today. Talk about it. Well, my name is Chris. Sorry, I'm Ken Logadick. This is Chris. There's Chris Piper. So we're going to talk about civil engineering as we go through it. We're going to just start building right away, and just talk about our program as we go along, and show you our lab and everything else. Okay, and we have Al's on the camera with us. So hey, Al.
Hello, everybody.
He's behind the camera. He's going to be he's the behind the scenes guy.
And if you want to add any chat comments as we go, please send them in. I'll watch for it here, and like anything you want to say, like cheer for one of us or the other.
Yay!
Go ahead and do that. Okay.
Oh, you remember, soil is fun.
So I'll be Team Structural Supreme over here. We'll see how it goes.
Perfect. Okay. Are you ready to go, Chris?
Can we start the timer?
Let's start the timer. Okay, let's do it.
So Ken has been here a lot longer than I have. He was actually one of my profs when I took the program.
What are you saying? I'm old? Is that what you're trying to say?
Experience.
That's a nice way to put it.
So give him that one. We are building a structure, so I hope that gives me a little bit of an edge.
Yeah, Chris is a structural engineer. I'm a geotechnical or soils engineer. We both graduated from this program. I graduated a couple years before Chris. And Chris, as Chris pointed out, I was his instructor when he was a student here. So just to tell you, so we do find a lot of the instructors actually have graduated from this program. So then we went out in the workforce, worked for a while, and then came back. So, and I also graduated and went on to get my degree, but and so did Chris, and we'll talk about that a little bit later on, and just to show you what's up with it all. But what we're going to do here, we're building some towers. What Chris and I have to build is we have spaghetti, hot glue, and 20 minutes. In that 20 minutes, each of us has to build a tower that holds the most weight. We're going to see who gets the latest tower and who holds the most weight. We're going to use these as our weight discs here. So that's why we're going to be building these towers as we talk to the deal. We're going to see who wins, whether it be structural or the soils guys over here, the geotechnical part of it. And they're both very important for any job, whether it be a building or road, whatever. Structural and soils are important for it. You probably see lots of civil engineering out there, lots of houses being built, roads, etc. That is civil engineering. So if you're wondering what it is, that is it. Civil engineering is what you see construction out there. Airports, whatever, it runs the gamut. Civil engineering is very, very broad. So on that note, Chris, you took civil engineering. Why did you take it?
Well, I entered the program as a mature student after working for a while, and I found I had to work out of town to make good money, which was great for a while, but eventually I wanted to be able to, make decent money and be home at night. And so when I went and learned about what was offered, there was civil engineering and nursing were kind of the top options, they said, if you want to get a good local job that pays well. And I just kind of could see myself in civil engineering a bit more than nursing, but that was my choice back then. And you know what, as I got into it, I kind of started to specialize in structural, and that was pretty cool. But it is a broad program. It gets you a bit of intro on all areas of civil, so it really allows you to get a large variety of jobs. And I haven't just sort of, narrowed in on one area only. I do, like to practice different areas. So I think the program's been really good in that way.
Yeah, so the program is very broad. That's a really good point, Chris. Just to tell everybody, I'll let Chris build a little bit while he talked the last time. You take about 32 courses in this program, which is about 8 courses a semester. So every 4 months, you're doing 8 courses. And they're quite different. They run the gamut from being structural courses, as Chris loves, of course, and from structural courses to soils to surveying, etc. And it's very variable. And we don't have different streams in the program or different options. We have no options. And the reason for that is we want to make sure you're a broad-based civil engineer when you graduate from here. And you have lots and lots and lots of job opportunities. And that's the biggest thing. And that's why I took it too. Like Chris, I wanted the job opportunities. Actually, my girlfriend was from New Zealand. Well, she still is. But I wanted to be able to travel with my diploma. And civil engineering, I knew would allow me to do that, to travel anywhere. It's nationally recognized and internationally recognized. So that was a big thing for me, is being able to take my diploma and go to different places, which has worked out very, very well for me. Oh boy, my whole thing's falling apart here, Chris.
You're already up out of the ground. In our practice session, I was standing up and Soils over here was laying flat, but I'm a little behind. But we're about 15 minutes to go. What should the students expect when they start the program? How much work are they going to have to put into it? How much time?
Oh, good question, Chris. The program itself is, gotta get this straight here. Program itself is quite demanding. You have to do 8 courses a week, and it's about 32 hours of classroom and lecture and labs a week. 32. So as you can tell, that's quite a bit type of deal. And you have a lot of challenges, just like Chris and I building these spaghetti towers here. My tower is not working out at all this time. This is really weird. Had a way better success last time. But you have a lot of challenges, which I think is great. And you, besides the 32 hours of class time a week, you have about the same amount of homework time a week. So it's quite intense, to say the least.
I'd maybe add to that, though, that you do get good support. We all have office hours, so you get good interaction with your profs, where you'll be able to ask questions and work through anything you're stuck on, and just to make sure that you are able to succeed.
Oh yeah,
so we're here and we like to help all the students.
How about office hours, Chris? During COVID, we don't really have office hours. What are we doing lately during COVID pandemic here? We still teaching some of the courses online and some face-to-face. Maybe you could talk about some of the courses you teach online and face-to-face, Chris.
Sure. So we're doing some of the labs I'm still doing in person. Like, for example, with the survey equipment, we'll use a total station to lay out a building or a roadway. We'll do those face-to-face, and then we'll do the lectures online. But with a lot of interaction, like the chat box here, I don't see a lot happening there now, but during lectures, often that's going pretty steady, getting a lot of feedback from the students during class. And same thing for office hours. We'll set up one of these sessions, students will join in, and we'll just work through whatever they're stuck on together until they get it. And I haven't really had, students leaving office hours without knowing what to do next.
Well, that's a bonus, Chris, for the students, eh?
Yeah.
That's good. So for your face-to-face labs for surveying, let's say, Chris, what do you guys really do for like the face-to-face during these COVID times?
So we meet up just out behind the lab building here, and we kind of discuss what we're going to do in the lab, and we put on our gloves and our masks so we're outdoors with masks. So in that case, we can be in little groups and work beside each other on the equipment. So we'll have maybe groups of 2 or 3 students, and we'll run the instruments and then go home and write it all up.
That's good, Chris. Yeah, I know even for my soil students, they have to hand in a lab every week, it is an intense workload, as Chris was alluding to here, and that's the biggest thing I do find that students have to deal with. It's a lot of work, and you got to be prepared for the work. And as long as you're prepared, you're fine. I find of the 40 students that we have that start, about 30 graduate out of that group. This is wrong side. 30 graduate out of that group, which is good. So we have about a 75% success rate, 75% success. And of that 75, out of the 25 that don't make it, it's usually not due to their technical aptitude. It's usually due to personal reasons and other things why they don't. They usually go do something else. Some people actually just change careers, they become a cook or something else. So good success rates.
I was just going to maybe build on the student success, like not just during the program, but afterwards. You know, once they're out there, once you're out there, even after, say, your first 8 months in the program, you're going to be you're going to be hired to do a job probably, and they're going to really rely on you. They're not just going to bring you in as a trainee. They're going to have you doing real work, and they're going to have, you know, real expectations of you, and you're going to be well prepared for it. The stuff I was teaching last year in my structural course, this is exactly what I was doing in the design office. So this is real stuff that's happening, and you're going to be ready for it.
And that's one real good point also, Chris, like Chris just mentioned, working in a design office. I work in a design office, Chris works in a design office. About half of the instructors, just over half, I believe, still work in civil engineering or during the summertime or even during the year. And so we keep current 100% with what's out there, with any designs, anything that has to be, any bylaws, etc. We keep current, we keep it up to date. It's not something 20-year-olds that we're teaching you. We're teaching you what we did this summer, and we'll talk about the theory, and then we'll connect it to, hey, this summer, you know, we just talked about blah, blah. I did a project with that. I did a project that had to use that this summer, and I go and I talk about what I did with that project. And so that's great, I find, for the instructors to connect the theory with the real world applications.
Yeah, I think the students really appreciate what we're doing being current. I see we're about halfway, and I know Al wanted to show you all some of the other equipment in the lab as well, but he's just going to kind of
have a look at what you guys are doing
see
here.
where we're at.
Well, you can see how much farther I'm ahead than Chris. Mine is up in the air. It's doing really, really good here. Chris, I think, is freaking out a little bit now. You feeling a bit of stress here, Chris? Are you?
I have to hurry
Feeling
up.
a bit of pressure, Chris?
Maybe stop talking so much.
And you will find engineering is all about what you can do with what you have, right? That's real life. So we'll let Al take you around back and show you all the equipment that we have back there. We'll talk to you a little bit, and Chris and I are going to keep building here.
Good luck, gentlemen.
Thank you.
I'll just walk back into the lab here. This is where we'll be doing a lot of the different labs. This is all the equipment that we have in the lab. Everything that's in here, you guys will be using. You can see that we have a station set up here for the COVID circumstances that we find ourselves in. So we're separating students with these dividers, as well as using face masks and gloves, and limited numbers for the space that we have. You'll probably notice that it says do not touch this equipment on a lot of stuff. That's because if we're not specifically using it for a particular lab, we don't want anybody touching and contaminating anything, so we don't have to clean. So that's the reason to see that stuff there. So this is a lot of the equipment that's in here is being used this semester and the following semesters. This is our large oven for drying soils. Ken likes to say that we can get 10 turkeys in there. We haven't tried that yet, but maybe one day we'll give it a shot. And we come into here, we have the main concrete lab. This is where we do a lot of fun, dirty work. You can see right now we're set up for doing concrete testing, fresh concrete testing. We literally bring a concrete truck up to the back door here. They remove the concrete from the back of the truck, just like they would on a job site, and do all the various testing for concrete. So, and we get to do a little bit of concrete finishing just to see what that part of it's like for people that are working on site. And yeah, this is where the magic happens, as they say. So lots of fun in here. Let's head back in and see what these guys are up to.
Probably slower one of the two. Oh, hey, Al.
Doesn't
Nice
look
to
much
see
different in here.
you.
So what's your strategy, Ken?
My strategy is to put as much spaghetti as I can on here. And actually, as you can see, I'm getting pretty good where it's really getting to be strong. It's getting to look like something as opposed to somebody's up there. Oh, you're up now.
I'm up out of the ground.
You're up there now.
What's your strategy, Chris?
I'm gonna unplug his glue stick.
Is it better to have a lot of spaghetti or a lighter tower? What's the best strategy?
Well, it is gonna be gauged as sort of a strength to weight ratio. So you know, as light as you can is gonna help, but you still gotta be able to hold a lot of this
Yeah, exactly.
stuff.
When Chris, just to tell you, when Chris and I were practicing earlier, so, but that's okay. It's not always the winner that gets it. It's usually who does it, who modifies it the best in the end.
Chris strikes me as a guy who knows how to hustle, though.
He definitely does.
Just gonna add some bracing here.
Yeah.
Hopefully that'll help it not to spin out when we put a little weight on it.
I hope it helps. You know, and that's what engineering is about. It's you know, as you can see, Chris and I were just working very hard, very diligently at making these spaghetti towers. And that's what it's all about. You're trying to make it using everything you got, every little bit of knowledge you have to like, okay, I got to reinforce it here. I think I got to put something here. And we got a time constraint. We have 5 minutes left.
You never have enough time.
Never have enough time. Talk about time. You guys can already apply for this program, just to tell you. Our application's open October 1st. And what you need to apply to this program, your minimum admission requirements are English 12, Math 11, and a Physics 11. Those are your minimum requirements. Why do we require, and you should know how to use a word processor like a computer. And why we have those, the minimum requirements, admission requirements, because we want you to be successful when you come here. That's our biggest thing. We want you to be successful, to succeed, to do well. Whoops, I broke my tower already. To do well and to be able to know how to fix things as you go along, like I'm doing here. Oops. And so that's the big thing that we stress here, is that you have to understand. Yeah, look at mine just falling apart. Al, don't show them how much glue I'm putting on. You know how it goes.
There's no restrictions on glue, is there?
No.
So you're covering admission requirements, that's right. And you know, I wanted to comment on that. When I went to join the program, when I took it, I couldn't get in the first year I wanted to because it was all full.
Yeah.
It typically does fill up. So, you know, registering, you know, I was ready the next year to register the day it opened, just to make sure I got my seat.
Yeah.
And I'm sure glad I did.
Oh, good. Yeah. Some years, Chris, we're really busy, which is good. And it's good for the students, lots of options for jobs. And that's what I want to talk about next is a bit of co-op jobs. Chris, you did a co-op job when you went through here, right?
Yeah, I was able to pick up work right in the first summer, got some structural work. I've been able to work with some of the professors here. And that kind of springboarded where I took off to and in structural. But I also did a work term as in a soils type job.
Oh.
And you know, I think that helps for Ken and I getting along if I know a little bit about soils, so we can talk a bit more.
Just a little bit about it, eh?
That's right. So Ken, I see we got 3 minutes left. I'm gonna try to get you to do some talking here. Still racing this thing.
Yeah, the co-op program, to finish off what Chris talked about, the co-op program. Co-op program, of course, is very popular here. What it is the employers come to us with jobs and they advertise their jobs through us because they know what kind of skill sets our technologists have. And the co-op program starts, you go 8 months of school, then you have 8 months of co-op. And you go out on your co-op program, the typical average wage this last year is about $21 an hour. And that's for a 40-hour work week out in the workforce, whether you're working in Kelowna or Fort McMurray, Fort St. John, wherever. There's a whole bunch of different job offers. Last 2 years ago, there's twice as many jobs as students. When I was a student, there was a lot of jobs in Toronto. When Chris was a student, there was a lot of jobs in Fort McMurray, the tar sand projects. Tar sands aren't that busy anymore. Toronto's busy still. But, and so it depends where you want to work. So there's a lot of different variety. I shouldn't say a lot of different, a lot of variety in co-op jobs, which is great. You can try different things. And that's what I did. I did one co-op job in forestry engineering and then one in soils. and ended up doing a lot of forestry engineering when I graduated, which worked out very, very well for me. But you know, you can do a whole bunch of different ones for your co-op jobs, and we'll see what works out well best for you. And that's what I love about the program. The co-op jobs is one of the best things. And you're job ready. When you graduate, you have 12 months of co-op work experience. That's huge, especially compared to a lot of other programs you can take that you have no work experience.
Like a degree type program, it's you know, after a couple of years, you may have had 2 years of school and not had a chance to practice yet before you're sort of ready to get that job in the industry.
Right, exactly. And we even have our students are job ready immediately. And that's huge, I find, for the students and for the employers, because they like our students because they're job ready right away. And that makes a very unique fit for everybody, because I work for an engineering company. We hire students too, co-op students. And that's our biggest thing, is to get a student that's going to fit, that's going to work, that can make, that they can learn something and do some meaningful work, and then we can charge them out on, and we can make money on them as the employer, because if we can't make money on the student, we can't keep it. That's really that simple. How's it going there, Chris? You're starting to feel the sweat. It's 1:14.
Trying to hustle. I've got 1 minute left. Oh boy, I better get some more strength in this thing. I'm just going to do a little
Is there
test
any
on
chat
this.
questions here in the chat box?
Nothing coming in yet.
Okay.
Feel free to cheer for structural or whatever you like.
Soils. Soil is good. No, soil is fun. Sorry. Just remember that. That's all you need. And see, even when I've tested here, I'm testing my tower. See where it bends out? As you can see, I don't know if you can see this. This one leg is bending out. So I should actually reinforce that. I don't know if I'll have time. We'll have time, Chris. It's 39 seconds. I don't know if I'll have time. I don't know if I'm gonna have time, Chris. Whoa, this blue gun is empty.
Just trying to add some more legs on this thing too. I think in the practice one, I did a little less bracing and just had one tall brace. And these extra braces took a lot more time than I expected.
And that's even when you guys start doing your homework, you got to think about too, right? Like,
10 seconds, gentlemen.
is it worth it to put that time in? Is it worth it? Come on, tell me. Is it worth it to do Chris's lab, or is it worth it to do my lab? That's your biggest thing you got to think about.
Is that it?
And time.
That's it. Hands off, hands off. Woo!
It's
Oh, they're both standing up for now.
That's great. They're doing awesome. I think they're doing great here. Oh, yeah. My glue is still so hot, it stuff's coming off.
Yeah, I got a couple pulling away as well. What, should we weigh them up?
Should we? Yeah, okay, let's try them. Okay.
What we got here.
Hey, both at the same time?
Yes. Oh, I don't need that piece to it. There we go.
Okay. Okay, 26.97.
And 30.94. Oh, I'm a little heavier. I got too much glue on the joints. So 30.94 is the mass of tower. 30.94 grams.
And mine's 26.90.
So should we tear the scales next?
Let's tear the scales. So we're going to tear off our scales so they both read 0. And we're going to start putting on our rubber discs. The bigger ones weigh a bit more, and the smaller ones weigh a bit less. But we're going to put them all on at the same time.
Hey, we got a question first. Just learn from my son. If he's not 100% sure he wants to be in engineering, would the common first-year engineering be a good starter to sort of get him introduced to see if he likes it? That's a great question.
That is a great question. The common first-year engineering program is meant to go, if you want to take first year and then go on to second year UBCO. So if you take common first year, you're going to get a degree, period. You're not in the technology program. If your son doesn't know what he wants to take, I would suggest a technology program, because even after 8 months, he can get a co-op job. And if he doesn't like it, the co-op job will easily pay for his tuition that he just paid the year before. So it's really, I think if he doesn't know what he's going to take civil engineering technology. And if he doesn't know what he's going to take now, which is a really good thing, you may or may not know it, apply for 2 or 3 different programs right now. Apply for a couple programs. And then you don't have to put your money down until February. So apply now. I tell people, apply now. Don't apply in June when the program's full. Apply now, put down your money deposits, and give up your deposit if your son doesn't want to go or daughter doesn't want to go later on. That's what I would totally recommend. But civil engineering or any of the other technologies, so you get a co-op work term, is, I think, better for us to start with. Because then you get immersed in. If you take UBCO or common first year engineering, you won't get a co-op work term until year number 3, between year 3 and 4. So you got to work, you got to be at school quite a bit before you know if you really like it. Good question, though. Good question. Okay, so let's start putting these on. We zeroed off, so put the big one on. Made this one too big to fit on the scale. I can tell I'm gonna have troubles.
Sounds like a personal problem.
Oh, it's a me problem, not a you. Oh, okay, next one. Oh.
Use some small discs.
Are you wimping out
Okay,
already?
let's do another big one.
Okay. Oh, we're going already.
So it might not win yet. I still have to try to get some more weight out of it, right? Okay. Let's put us some small ones.
Look at you go. Oh, Jesus, you beat me. I'm done. Look at this. I'm admitting defeat already.
What's important here is I've got a solid foundation, which is what a soils would provide, right? This is why it's critical that we work together out there.
That's right. I made it too big. I didn't talk to the structural engineer at the start. I just made it bigger than what I needed, and I shouldn't have done that. I should have made mine smaller. Oh, well, that's why we have to work together as a team. You're doing great here, Chris. Look at this. Look at you go. Holy cow.
Oh, wow.
I got beat big time. This isn't like our trial one, by the way.
Yeah, those extra braces really paid off.
That was totally paid off.
I guess it does pay to hustle the first one.
2.1 kilograms.
Oh, nice.
2.19 kilograms. 2190. Let's see.
Okay, let's do this.
Yeah, about 2190.
2190. Okay.
I had 3, so I only had 350.
2190 grams.
Yeah, I think you beat me because I'm like,
Let's see our strength to weight ratio.
mine is only like 12 or something like that.
2190 divided by 30.94. So I got 70.
Yeah, I'm 11.
70.78.
I'm 11 if we lose.
Is a strength to weight ratio. And now in the practice one, I got only 50 and Ken got 60.
65. What was yours this time? 11.
Oh, yeah, it was because of that base thing.
Yeah, because of the base.
You know, we should have given you a bigger base. I'm sorry about
Oh,
that.
that's okay. I'm okay with it.
It was a good.
It's a good one for civil engineering, to say the least. I think it was great. Oh, I think there's a prize actually that you won here too, Chris. You might want to look up.
Oh,
It's coming out yet. It's coming out yet.
and if anyone wants some of the civil engineering draft, like some rulers or lanyards, send us a note.
Yeah, we'll try to get it to you. And especially once COVID, hopefully when it passes, we can always do tours in the lab and stuff like that. So, so I think that we're going to wrap up. I think we'll go to the wrap up slides now. We just have a couple of slides we're going to wrap up with you. And we'll be available after these for chat. If you want to do anything with chat or audio, you can always chime in with us. So here's a couple of the wrap-up slides for our virtual open house, or explore, ask, and apply. That's the big thing. We're so happy you joined us today for our session. Hopefully you can look at some other sessions too. You know, don't make your decision right away. Look at all sorts of other ones. Try all sorts of other programs. Check it out. Look online, see what jobs are available, etc. I always tell people, look online, do everything. Look, see if you can actually get a job out of what you get your degree or diploma in. Always check that out. If my buddy, he took a zoologist program, literally, and then he came through here and got his diploma, and he's doing really, really well now. He's manager of a couple of consulting firms. So be careful what you take and make sure there's jobs out there for us. And ask as many questions as you can. Chris and I are always available. You'll be able to find our web email pages on the web page. Just email us anytime you need anything, and we can get back to you. And apply. How do they apply, Chris?
So we want to call you to action to register. There should be a link on the slide here. Apply on the very bottom there, I see it. So if you go there, and that's the web address, and there's also a $5,000 tuition prize. Okay, so
Awesome.
enter for that, and I believe when you apply, it automatically enters you in.
Perfect. That is great.
Just apply.
Just apply. Well, Thank you, everybody.
Thanks for joining us for this
Thanks for
build-off.
joining us for this lovely build-off that Chris won, but which is good. Thank you, Chris, for building with me. So it was good. Again, we're going to stay on after we clean up our towery mess. Thanks again. Have a great day, everybody. Thanks from the Civil Engineering Technology.
And I did see another chat message. I will just
please.
reply to that as we're
Bring it up.
finishing up here.
Go for it, Chris. Perfect. And if you want to unmute your video, you can unmute your audio. Sorry, not your video. You can, and we'll answer any of the questions. As Chris eats his Smarties and replies to other ones. Oh, I forgot to mention the civil engineering technology, different jobs. As you can see right in front of me, you might not have noticed right below my hand here. Those are the different companies which just have different jobs for us. Different ones. I know Al's probably coming back to it here in a minute.
So many buttons.
Yeah, right underneath. Here's the civil engineering technology. There's different companies down here. Nice. And so, which is great. And I'll give you a close-up of that. So those are some different companies around Kelowna and Alberta and that have different jobs. Students have done different co-op jobs there as well as graduate students. And we do find that a number of our graduates do stay in the Okanagan Valley, about 80%, 20% go elsewhere. And we do find about 95% of students that graduate do go into civil engineering. They stay in and they get well-paying jobs. Graduate jobs are about $60,000 a year right now. Right, any other chat box ones or any ones that people want to ask? Any questions?
That's a wrap.
That's a wrap. Well, thank you very much for your time, everybody. Have a great day.